Okay. So, obviously congruent. Same size, same shape. Very good. Similar polygons are the same shape, but different size. Same shape, different size. So how are they the same? The shape remains the same. The angles remain the same. Do you remember that from dilations? The angles do not change. You don't use a scale factor with angles. So the angles stay the same. The overall look of the figure is the same. The only thing different is the size. The only thing different is the size. Here's some similarity in the real world. When people make doll houses, they're taking a big building or a big thing and then they're shrinking it down. When people make buildings, first they make a model of it. I can't tell you how many models are in my house because my husband's an architect. So first they make it on a small scale and then they blow it up to a large scale. So you can go both ways. When people paint a mural, I don't know if you can tell, but that's a mural painted on a building. First you usually sketch it small and then you blow each section up and make it larger. This is cool down here. This is a wind tunnel. And so this is a small version of an airplane. And they stick the airplane in the wind tunnel to see how it reacts to certain wind. So it can see what a real plane would do when it's caught in a bad situation with lots of wind or something. So they do like little simulations in here and test out airplanes. So they take something big and they make it smaller to see how it will perform. So, similarity. Most important slide of the whole day, right here. Scale factor. When you're finding a scale factor to blow up or shrink a figure, you always put the second value over the first. Second over first, second over first. If you walk away with nothing else today, let it be second over first. Got it. Once you find the scale factor, you can use it to multiply to find missing sides. So that's how a scale factor is useful. Second over first. Second over first. All right, let's try it. Number 1. Scale factor. So we want to go from the small one to the large one. Do you remember from dilations what has to be true about our scale factor? Raise your hand if you remember. If my shape is getting larger, what is our scale factor going to look like?
Plus.
What, Kendall?
Positive.
Okay, more than that, more than just positive. My shape is getting larger. Is my scale factor going to be like 1/4? Larger than 1. That's what I was looking for. Okay, so if I'm getting bigger, my scale factor is larger than 1. If I'm getting smaller, my scale factor is less than 1. So let's do our new rule. Our new rule is second over first. Second over first. And we would never in a million years ever leave our answer unsimplified. So you can either simplify that in your head or you can go to your calculator and do 6 divided by 4, math, enter, enter. If you are not excited about simplifying this in your head. But either way you're going to get
3 over 2.
3 halves, 3 over 2. So the answer to A is 3 halves. What is that as a decimal? 1.5. Okay, so that would be acceptable too. I normally like scale factors as a fraction, but putting it as a decimal would not be incorrect. 1.5 is the scale factor. Okay, everyone do B. Write your answer on your paper. What is the scale factor for that heart? Look at which way the arrow is going. Be careful. Which figure is the second figure? Is it getting bigger or smaller? Let me rephrase my question. Is it getting bigger or smaller? That shape got bigger. So your answer better be greater than 1. These are coordinates. So which coordinate do I use? Do I use the X or the Y? Which one? Trick question. Doesn't matter. It doesn't matter which one you use. You can use the X or the Y or both. I don't care. It should be the same answer or else they're not similar. All right, so do 4 divided by 1. What do you get? 4. Do negative 8 divided by negative 2. What do you get? 4. What is the scale factor? 4. That means this heart is 4 times bigger than that heart. Divide. You divide. Second over first. What are y'all talking about? Did you already do C? What'd you get?
C, I got 3.5.
Catherine, what'd you get for C? Second over first.
Oh,
What do you think? Okay.
2/7.
Alea, what'd you get for C? Yes, very good. 2/7. You can't reduce that, but I was calling names, so I ignored you. You cannot reduce that because there's no number that divides into both of those. So 2/7 is the final answer. Second over first, so it's not 7/2, it's 2/7. You put the number from the second figure over the number from the first figure. Let's move on. Okay, the scale factor will help us uncover the mystery of the missing sides. So let's say we are missing this side. Oh no, it's gone. But we know it goes with that side. So we just need to see how much bigger is that other figure. How much bigger is that other figure? So let's look at two sides that we do know. We do know this side, and we do know this side. So Ashley, what's the scale factor? Second over first. My underlined ones.
2.
Very good. The scale factor is 2. That second shape is double my first shape. It's double. 2. So to get from here to here, we are doing times 2. So what number can I multiply by 2 to get 6? 3. Another way to do that is if you're going backwards, like if you're going from here to here, you could just divide by 2. You can use the scale factor both ways. Forward you multiply, backwards you divide. 6 divided by 2, that means that's 3. It's half as big. What about this question mark? Don't say it. Dimitri, what about this question mark? How long is side DC? Look at what side it goes with. What side does it go with?
Is it 5?
It's totally 5. It is half of 10.
Yay.
Yay! 5. The scale factor was 2. So do you see how we use the scale factor to help us find missing sides? Yes, you did. Okay, moving on. Do number 3 by yourself. Go. Do number 3 by yourself. Go. Number 3.
Oh, wait, I was supposed to write.
Oh, sorry. Did I have that on the slide?
Yeah, we got last time.
Sorry, guys. Kind of glazed over this. Okay, right here, down here. When you're going forward, you multiply by the scale factor, and when you're going backward, you divide by the scale factor. Forward, multiply, backward, divide. Forward, multiply, backward, divide. Thank you, Megan, for pointing that out. Okay, now I'm going to move on. Okay. Now you can do number 3, scale factor. Simplify it. Second over first. That's all you have to do. Second over first. Julius, what's the scale factor? Give me a number from the second figure. Here's the first figure. Here's the second figure. Give me a number from the second figure. What number does that go with? Put the second over the first. Okay, well, but I like fractions better. So 10 over 8, you told me that. And then what is that as a simplified fraction? Julius? What's 10 divided by 2? Yeah. What's 8 divided by 2? Okay, so there's our scale factor. It's 10 over 8, but 10 over 8 is not a good answer. So 5 over 4 is our simplified answer. 5/4 is the answer. You can also write it as a decimal, but we like fractions better. All right, so now we need to find J. Are we going forwards or backwards? In my head, we're going backwards because we're going to the first. So I would take 20, and what does it say to do if we go backwards? Just divide by the scale factor. 20 divided by our scale factor. That looks really scary, so ask your calculator what that is. Go to your calculator. 20 divided by 5/4. 20 divided by 5/4. What do you get?
16. It's right here, Mrs. Sits. Wait, you
20 divided by 5.
Yep, 16. Sounds great. Make sure you put 5/4 in parentheses. That's what some people did wrong.
Or that
20 divided by 5/4. All right, and then Lewis M., the measure of angle Z. The measure of this angle.
Bam.
These are similar figures. 38. Ding, ding, ding. Do not ever use a scale factor on an angle because the angles stay the same, the angles stay the same, the angles stay the same. Okay, moving on. Math is similar to kids. Have I said yet that this means similar? I don't know if I've said that. That squiggly means similar. Math is similar to kids. All right. What is the measure of angle A? I don't think we know the measure of angle A. Oh, but it's not asking the measure of angle A. Angle A is congruent to which angle I'm going to call on Megan. What does angle A go with? Good. Angle I. Let's see. What does angle K go with? Or sorry, what is the measure of angle K? Because that's an equal sign. What is the measure of angle K? 90. Very good. Brett, what's the measure of angle T?
50.
50. ID is to AT as IK is to Nasia. ID is to AT as IK is to what? AM. Very good. You're just looking at the order. We're looking at the order of the letters if you were curious. We're just using the order of the letters. Ava, what's the scale factor?
5, 6.
Let's see. Yay, beautiful. 5, 6. Very nice. And Shelby, have you found DS yet? Okay, let's work on it. So you're just going to multiply by the scale factor. 18. Remember, we're going forward, so we just multiply. 18 times 5, 6. And tell me what you get. 15. Very nice. 15. All right, moving on. Very good.
15.
The answer was 15. We just multiplied. We used our fancy new scale factor and we multiplied. All right, 1, 2, 3, flip. Or did we flip? No. Dimitri flipped. You confused it. We're on the last example. Yeah, we did. I went back to it. Shelby even asked me to go back to it, and I went back to it. We're going forward. We multiply it backward divide. All right. Look at these stars. What's happening? They're shrinking. My kids were just watching Despicable Me, so it's like he's using his little shrink gun and shrinking the moon. Shrinking the stars. Okay, so these are decagons technically because there's 10 sides, so these are decagons, not stars. What is the scale factor from star to star? Torin, how do we get scale factor? Remind me. What's the one thing I want you to walk away with today?
The second over.
Second over first. So that's all you need to do, guys.
So then 7.2 over.
Second over first. Do it. Ask your calculator. 7.2 divided by 8.64. That's so ugly, but your calculator can make it prettier. Put it in your calculator. Let's just do a decimal this time. What is it?
23.
0.83 repeating. Okay. 0.83. We'll just go with that as the scale
Should
factor.
we put the?
Yeah, you can put the bar. Sure. What is the length of the side of the smallest star? So we're looking for this. That's X. So how we find that is we take the one before it. We take the one before it, which is 5, and we multiply it by our brand new scale factor. What's our scale factor? 0.83.
Yeah.
So 5 times 0.83, we're making it smaller because 0.83 is less than 1. So we're making each side smaller by 0.83 every time. So Matt, what is 5 times 0.83? You need a calculator? Dimitri, what is it? 5 times 0.83.
Here you go.
Oh my gosh. Seriously.
I got this. It's his turn.
Kendall,
4.1.
Kendall, you stole his shine.
0.15.
Yeah. Point five.
Okay, tomorrow Matt will get his calculator. All right, end of story. Done.